Hello dear students, a very good afternoon to all of you. Welcome to another video of Master Arduino like a Pro. We have come over here with another video with a new project and we will learn something new as we already do. Alright, so let's move ahead. I believe that you all have watched the previous videos as well. Let me give you a quick brief about myself. If you are new over here, my name is Ahmed Sir. I am a coding and robotic expert. I have completed my MSc and B.Ed from the University of Mumbai and a senior master teacher at sisyaclass. I've taught around 1.2 lakh students all across the globe. Coding, robotics and web development is something that I have expertise in. So without much ado, let's get started. I would really like to welcome you all to the sisyaclass family with us over here. So welcome to sisyaclass. sisyaclass is all about online learning platform where we teach the students of school and college level in the online platform in our application. We have IITians and NITians who have crafted their curriculum very carefully and make sure that this curriculum that we are delivering to the student is up to the mark. Okay. So what are the things that we are gonna talk about? So far in the series that we have of this video of, the series was of total 6 sessions. Out of the 6 sessions, 4 are already completed and we are today in the 5th session. Today's topic is gonna be how to power and control a servo motor with Arduino Uno. But basically, we'll first of all see that what motors actually are, and then further to that we'll see that what are the different kinds of motor or basically rotatory objects or components that we can use in robotic projects. We'll see that what are the difference between these all rotatory components, and then further we'll try to understand in depth how servo motor actually works. Once we do that, then we'll be moving ahead and we'll understand that how to program a servo motor. Okay. So these are the topics that we will be covering today. We'll see types of rotatory component, interfacing with servo motors, understanding the working of servo motors, and follow to that we'll have project automatic dustbin lid system. Okay, and this is how the project will look like. We'll have a better understanding about this in the coming slides as well. Okay, so I believe that all of you are super excited and all of you are with me. Give me a thumbs up in the chat if you are with me. Okay, let's move ahead now. Moving ahead, the next thing that we have is basically we'll be talking about the types of rotatory components that we can use in robotic projects. Okay, so most common rotatory object that we use in robotics project will be DC motor, servo motor and hobby motor. Okay, now let me help you understand that what is the difference between all of these different types of motor. The very first and the most common motors among young students is DC motor. Okay, now DC motor are very small motors that you actually get from toys, broken toys, or you can also get it from your stationery shop, and usually school students use this to create science projects like windmill or any part in the project which requires something which is rotating, right? So these kind of projects are the places where you will be using DC motor. DC motor will have only 2 pins. We have the positive and negative pin, and once we supply the necessary voltage and current to it, it will start rotating at a given direction. Okay, now the rotations can be calculated based on RPM, which stands for rotation per minutes, and the RPM can be increased or decreased depending upon the change in the voltage that we are supplying to the DC motor, and that's how we can speed up the rotation or slow down the rotation. Okay, so this is what DC motor is all about. Okay, moving ahead to the next type of motor that we are going to use in today's session is going to be servo motor. Okay, now servo motor is special in contrast to DC motor in a way that we can actually control how much rotation can be done. And when I say control, you have the precision of up to 1 degree. So even if you want to like move or rotate the axle to 20 degrees, if you give the correct input to the servo motor, it will actually move exactly 20 degrees, not more, not less. Okay, so that's how the precision with servo motor is. Now servo motor will be used in such cases where movement or angular movement is supposed to be done very precisely. Okay, if it is required to be done very precisely, we'll be using the servo motor. Okay, moving ahead, the next thing is hobby motor. Now hobby motor are usually used for projects where cars are involved. Okay, so like a radio frequency controlled car, or remote controlled car, or we can say line following, path following robot. All of these things which requires more torque, right? More torque is nothing but rotationary force. Okay, so projects which require more torque is the place where we will be using hobby motor. Okay, well, motors are not just limited to these three. We have tons and different types of motors also, and if we keep talking about that, then even talking the whole day will be very less. Okay, therefore what we are going to do is we're going to just stick to these three types of motor. In tomorrow's session, when we are going to create a very big project together, we will be using DC motor, and we'll see that how DC motors are actually used. However, in today's session, our main focus will be on servo motors at the moment. Okay, let's move ahead now. If you have any questions, please drop in the chat section, and if you want to see any specific project to be explained by me, drop your suggestion in the chat section so that I can create a plan, and I'll get back to you with the same project and the explanation of it as well. Okay, moving ahead. Fine. So now here is a detailed explanation about servo motor. Okay, as I've mentioned, whenever we talk about any new electronic component, the very first thing that we're going to do is try to understand the purpose of that component. Once we understand the purpose of that component is when then we'll understand the physical properties of it, where we'll understand that what kind of pins are there and what kind of input and output it will give us, right? Okay, so step number one, we'll see that what is the purpose of servo motor. Now servo motor will give you rotation. Okay, it will give you rotation. Usually the range of rotation for servo motor is 0 to 180 degrees Celsius. Okay, from 0 to 180 degree. Okay, this is the range of rotation, which means that it doesn't rotate complete round, but it will just rotate one half circle, and then again it can come back. So it has a range of 180 degrees, 0 to 180 degree. Okay, that's where we have covered this point. The range is 0 to 180 degree. So if this is the axle, okay, so it will move like this all the way up to here, which means that this portion will come down over here, and this portion will come up over here. Then we'll say that 180 degree has been completed. It will not be able to move further than that. Okay, however, there are special servo motors which can move more. Their range is much more better. Okay, in fact, if you want a motor which can rotate complete 360 degree but with a controlled precision, we have a different type of motor that we can use, which is called a stepper motor. Okay, we are not covering that in today's session, but any which ways, this is something that we should know about servo motor. Okay, fine. So where can we use this? We can use this in projects where we want to open or close a door, we can open or close a lid, or else we can use it in robotic arms. For example, if you look at my elbow, it has a certain limited range of motion, if you can see over here, right? So this action, if you want to mimic inside or through a robot, you can use servo motors actually. I believe this is clear to all of you, right? Okay, now what we can say is, now servo motor is usually interfaced with PWM. Okay, now what does PWM stands for? PWM stands for pulse width modulation. Okay, now pulse width modulation is a kind of a digital signal, but it sends signal based on the number of bits that we have, and at the same time the length of the A signal, or I would say one signal, will be elongated to represent a certain data. For example, if I want to transfer a certain data to servo motor, right, and let's say that I want to transfer 10110, right? So what will happen is a graph will be created. Okay, like we can create a graph for our understanding that how the pulse width modulation frequency will look like and how its graph will look like. Okay, so let's say that this here is a graph. Okay, here we want to create the graph. and for every 1 it will come here, and for every 0 it will come here. Okay, and what we'll do is this will be against time, so it is velocity, it is sorry, not velocity, voltage along time. Okay, it is voltage along time. Okay, now if the voltage is high, then we'll mark a dash over here, and if the voltage is low, we'll mark a dash over here. So we have high voltage, so 1, low voltage over here, then again high voltage, and again high voltage, then low voltage. Now if you connect all of these, you will see that this is how the wave will look like, right? This is how the graph will look like. And now if you see, the width of this pulse is modulated as in it is different. Now this is a very simple and simplified version of what pulse width modulation actually is, but the thing is, in reality what happens is every bit is coded with a certain width of pulse, and then when a certain width of pulse is emitted, then the receiver of that pulse will understand that okay, this is the so and so data, and it will act accordingly. So that is what pulse width modulation is. We can have an entire 1-hour lecture completely to understand what pulse width modulation actually is. Okay, however, for the sake of simplicity, we just need to know that pulse width modulation will modulate the width of the pulse. This is the width of the pulse to encode a certain value, and that value will be sent to the component. Okay, fine. So we understood that it uses digital pin, but the signal will be not completely digital. So it is digital, but a special kind of digital signal, which is called as pulse width modulation, PWM. Okay, now can control up to which degree the rotation should be made. We can use this project in a situation where we can control that how much degree the rotation should incur. Okay, then it has a precision of 1 degree, and it is especially used for applications where very precise rotations is expected. Now some example of these kind of projects is robotic arm, dustbin lid, or door movement, etc., as I've already mentioned. Okay, now since now we have understood that what is the property of this robotic component, the next thing that we need to understand is the physical property of it. Okay, now looking at the physical appearance of it, we have some connectors, and then we have the actual motor part over here. And in the motor part, you will see that this body is semi-transparent, so you can see some of the inner parts inside it. Okay, now one thing which is protruding outside is the axle, and on the axle we have the arm. So as the axle rotates, the arm will also rotate. This arm can be used for getting the movement done for the doors or the lid of any boxes. Okay, now this is the place where we will get the rotation from, and we can utilize that rotation, okay, in our project. Now coming to the connectors, we have total 3 terminals over here. Okay, the first 2 terminals is the power terminals. Okay, which means that we will be supplying power and then connecting it to ground so that the circuit is completed. And once the circuit is completed, we can say that the servo motor is ready to operate. Okay, then the next thing that we have is a signal. Now signal is a place where it will receive the PWM or pulse width modulation. It will receive PWM signals from what? It will get PWM signals from the Arduino board. It will get the PWM signals from the Arduino board. So Arduino will output the PWM signals, and the servo motor will take that or input that PWM signals. Okay, I believe this is clear to all of you. Okay, so based on whatever PWM signals you send it over here, the servo motor will understand to what degree it is supposed to move, and based on that it will move to that particular angle. Okay, let's move ahead now. So okay, now in order to interface with servo motors, we'll need to use a special library. Now let me explain you what library is. Now library is actually a set of program that is written by someone else. Okay, and this becomes very convenient for us because we can use someone else's program in our program. Okay, this gives us the ability of reusability, and therefore your program will turn out to be very short. Why? Because you're using someone else's program to meet your needs. Okay, now in order to use a servo motor, the external file, which we call it as a library, is called as servo.h, as it is written over here. The name of the external library is servo.h. Okay, and the way that we can include this in our project is by writing this line of code. Okay, this is our first step. Okay, step number 1 is to include this library. Okay, until unless you don't include this library, you can still achieve the target, but then you'll need to write all the codes yourself. Okay, which will be a really time consuming stuff, and at the same time your code will be very bulky, which means you'll need to write so many lines of codes. Okay, but this library, we have the codes already programmed by someone else, and we can use that. Okay, so we have the syntax to write is #include. So include is a keyword in C++ language, which tells that we need to include this library in our project. Okay, so #include, and then the file that we want to include in our project, which is enclosed within angle brackets. Okay, this bracket are called as angle brackets. Okay, so angle brackets will be enclosing servo.h. So this is how you can include the library. Apart from that, the entire program for Arduino will still remain the same. Okay, all the digital write, digital read, everything that we want, we will have void loop and void setup also. Everything will be the same. I'm just focusing on few important new commands or new functions that we will be using, that is coming from the servo.h. Okay, so the second thing that we're going to talk about is creating an object of servo. Now basically, if you already have some knowledge about object oriented programming languages, in that case everything that you code is inside a class. It is enclosed inside a class, and whenever we want to access anything from the class, we will be basically creating an object of it. Okay, so here the name of the class that we are going to use is going to be servo. Okay, and from this I want to create an object for this class, then the name of this object will be named as servo9. Okay, now whenever I'll say servo9, it means that I am referencing to my servo motor, which is this one. Okay, and using this object I can call other functions, and then accordingly I can make the servo motor work. Okay, so this is the third thing. We'll be creating the object so that we can access the variables or the functions of the class which is there inside servo. Okay, then the next thing is that we need to set up the pin. We need to tell that this object is connected to which pin number, right? To which pin number will it communicate? So for that we'll have a function which is called as attach. Okay, now right now, so far what we were doing is we were calling the function directly. Why? Because it was an inbuilt function of Arduino program. In today's session, what is different is that the program that we are going to use is an external program that we have included in our project, and because it's an external program, we need to use the object to call that function. Okay, so the object that we created was servo9, and then we used the dot operator over here to use that object to call the function from that class from where it belongs to. So I'm saying that, hey servo9 attach. So attach, there are three parameters that we need to pass. The first parameter is pin, second is min or minimum, and the second one is max, which is maximum. Okay, let me explain what is min and maximum. Okay, now pin number will explain that which pin number it is connected to. So we can connect any digital pin. As I've mentioned that it will require PWM, and PWM can be generated by digital pin only. Okay, so we can use any digital pin. So I'll write DP over here. Okay, now let's try to understand min and max. Okay, so let's say that the rotation range of this servo is 0 to 180, which is true. Okay, for this servo, so we'll say it can be at this arm can be, okay, I'll just name this end as A. Okay, so this A can be at this point where the angle can be considered as 0 degree, which can be considered as its initial position, and then from here it can move all the way over here and come this point also, right? If it rotates and comes to this point, then the angle will be considered as 180 degree. So this is the range. Okay, now when we talk about range, okay, once we know the range, every range will have a encoded number. Okay, and this encoded number will help to create a PWM. Okay, in my case, in this case where we are using this servo motor, the minimum value is 500. Now what does 500 means? Which means that if my arm is set at 0 degree, then the value that we are passing should be 500. So 500 refers to 0 degree. Okay, and this can be varied, this can be different for different servo motors. So it depends upon what kind of servo motor you're taking, what is the manufacturer's specification with respect to that servo motor. This number can change. So it's always best that whenever you buy any servo motor, you also check its data sheet. The data sheet will have all of these values, that what angle corresponds to what number. Okay, so basically we are not interested with all the angle values, but we are more interested with the initial angle value and the final angle value. Initial is 0 and final is 180. So looking at that, 0 degree is corresponding to 500, and therefore minimum, instead of writing minimum, we have written 500. Okay, then maximum will be 2500. Maximum, if you want, then it is 2500. Now once you have created this attachment, so you created an object and then you use the attach function. Attach function will have all the values, that which pin number this servo motor is connected to, then what is the minimum and the maximum rotationary range of it, and the corresponding value of it, and these two things will be attached together. Now Servo 9 knows that which servo motor it is controlling and in which pin number it is connected to. Okay, now once that is done, then we can control it. Then we can say, hey Servo 9, basically Servo 9 is the name of the object. So we can say, hey Servo 9, write means perform this. Perform what? Write pause. Pause can be the position. So we can put any number, and then accordingly we will get the servo motor rotated in that particular angle. Okay, so that's how these things can be done. So 4 things that we have learned new about this library. The first thing is adding the servo library. Second thing is creating an object of servo. Third thing is setting up the pin, and fourth thing is making the servo move. Once we understand all the things, these are your new learnings that you have learned in this session. Then we will be using this in our existing code and will modify it in a way that we can create some own projects. Okay, I believe this is clear. If you want any explanation to be repeated, please drop into the chat section. I'll happily do it once again. Okay, moving ahead. So this is our project objective. Okay, we will power and control a servo motor with Arduino Uno. Okay, basically we want to connect Arduino Uno with a servo motor, and then we want to power it up and then make it rotate. If it is rotating, then we are happy. That's our objective for today's session. Okay, so yeah, I think it's time to do the coding part. So are you all ready with me? Right? All right. Okay, so we'll start with the coding ahead now. We'll discard this, and then we can move to our Tinkercad, and as we already do, we'll create new circuit. Okay, once your circuit is completely ready, then your project is ready, then you can move over here, and then I'll tell you one thing that we haven't used so far is you can click on this basic components and then click on Arduino, and with this you will get tons of different pre-made projects that you can explore and get your hands dirty with. So there are tons of different projects that you can work with. You see here also, and this will help you to explore more and understand that how different types of components can be interfaced together to create different projects, right? Okay, but however, with interest of time, what we will do is we will use a project that is created previously. Okay, we'll use this one, and I'll explain you the entire connections first. So this is the project right now. Here is a servo motor, and here we have the Arduino Uno. Okay, now if you look at the connections, it's pretty much straightforward. We have 3 wires or 3 connections. The first connection is for ground, the second one is for power, the third one is for the signal. Okay, so if you see, the green one over here is connected to signal, and this is pin number 9. Okay, then we have the red line, which is the power line, which is connected to 5 volt. So its operation voltage is actually 5 volt. Then we have ground, and ground is basically connected to ground. So that's how the connection will look like. Very straightforward, simple to understand connection. Okay, 3 wires, power, ground, and signal. Signal will be connected to any other digital pin. And if you look over here, in this digital pin, it's written digital plus it is written PWM. Now PWM comes with this tilde symbol. So all the digital pin which has this tilde symbol means that pin is enabled for PWM, which means that not all digital pin will pulse PWM signals. Okay, so yeah, we can choose 11. Okay, I'll say we cannot choose 0, 1, 2, but we can select 3. We cannot select 4, but we can select 5, 6. We cannot select 7, 8, but we can select 9, 10, 11, and then we cannot select 12 and 13. How do I know this? Because of this tilde symbol. Tilde symbol is nothing but a wave like symbol, and it is marked over there. Okay, it's pretty simple and straightforward to understand that which pin can be used over here. Okay, so yes, in case of connecting the servo motor, we can connect it with any of the PWM pins, which is 3, 5, 6, 9, 10, 11. Okay, I believe this is clear to all of you, right? Well done. Okay, and then we have the power pins and the ground pins connected over here. Let's try to see the code. Clicking on the code right now, the very first thing that we have written is to add the library, and as I mentioned, to add a library we'll use the keyword hash include. So we'll write hash include, and the file that we want to include enclosed in angle brackets. So we have server.h enclosed in angle brackets. Okay, then the next thing that we have is position. So for position we'll create a new variable. The name of the variable will be called as pause. Okay, and pause will be set as 0. 0 means initial position 0 degree. Okay, then we have servo. This is the name of the class, and then we are saying that create a new object of the class servo and name this object as servo underscore 9. So we'll name it as servo underscore 9. Moving ahead, then we have void setup. Inside the void setup, we are gonna do the attachment part with the object and the other values that we have. Okay, so inside void setup, I'm gonna say servo.attach. Okay, servo is the name of the object, and servo will be calling the function. The name of the function is attach, and then we are supposed to pass 3 values. The first one is the pin in which the servo is being operated at. The second thing is then the value of minimum angle, and the third one is the value of the maximum angle. As we have already mentioned, we are going to write servo underscore 9 at the dot attach 9, 500, 2500, and mark my words, if you're doing it Tinkercad, this is the number that you will be using. However, if you're doing it with a physical device and you have a different servo motor as compared to mine, then you will need to read the data sheet of your servo motor and try to understand that what number you're supposed to put over here. If you're doing the wrong numbers, if you're inputting the wrong number, your servo motor might not even work, or might work but it will rotate in the wrong angle values, and you will not get precise movement in your servo. Okay, now moving ahead, that is the only thing that we will be covering in a setup. That we are just setting up the pin and the object values. Moving to the next part is loop. Okay, now loop is something that you will keep on doing again and again. Okay, now what I want is, if this is the arm of the servo motor, I want that for every fraction of second this servo motor should move and do a complete 180 degree rotation, and after 180 degree rotation it should come back and be at its position. So once what we are doing is we are giving a positive rotation, and then once the rotation is completed, then we'll move to negative rotation. Okay, so we have positive rotation and then negative rotation, positive rotation and then negative rotation. That's how the rotation is expected to be. Okay, so for that what we are going to do is we're going to use 2 for loops. One for loop will be for positive rotation and the other for loop will be for negative rotation. Okay, talking about first for loop, we'll write position is equal to 0, and this position will go up to 180. So it will start from 0 and it will go up to 180, from 0 to 180. Okay, and then for every iteration or for every completion of loop, the value of position will increase by 1, which means that for every iteration the servo motor will move 1 degree, 1 degree, 1 degree, 1 degree. It will keep on moving like that. Okay, so this is the for loop. Apart from that, then we have servo 9.right. As we have mentioned, to make the servo move at a particular angle or rotation angle, we will be using right function. So we'll call the object name servo 9.right, and then we'll pass the value that how much degree we want it to move. So we'll say that post value, which means that if I pass it 1, it will move to 1. If I say 10, then it will move to 10. If I say 45, then it will be 45, and like so. Okay, so basically this loop will keep on changing from 1 to 180. So one by one, what will happen is the servo motor will get values like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up to 180. Okay, and till the time it reaches 180, the servo arm will also move a half rotation. Okay, and with every iteration there will be a delay of 15 milliseconds, which is very small. Okay, fine. So this is how the positive rotation will happen. Now once the arm is over here like this, we want to bring it back. Now for bringing it back, its initial position is 80 and then its final position will be 0. So we want to make it come from 180 to 0. So therefore, if you look at the second for loop, we are initiating the pause value as 180 and then this value will come down to 0. Once it is coming down to 0, then we can say that this is completed. Okay, this is completed, fine. Then moving ahead is the next thing is that for every iteration in this loop, what is happening is the value of pause is getting decreased. Okay, here the value was increasing because you are moving from 0 to 180. Okay, now in this case it is happening reverse. We are starting from 180 and coming down to 0, and therefore we have a decrement operator over here rather than increment as compared to the above one. Okay, again the same thing, we will write the position values over here and then we will have a delay of 15 seconds. Okay, once this is done, then the entire thing will again repeat once more. Okay, so that's how the code is. If you click on start simulation, you will see that the servo motor is rotating. Half rotation is done, then it will come back. Half rotation is done, then it will come back. Half rotation is done, then it will come back, and half rotation is done, it will come back. So 180 degree is the range of this servo motor, and therefore it is making half rotation and then coming back to its original position. So two types of rotation, positive rotation and negative rotation. Therefore we had two for loops over here. One for loop was starting from 0 to and it was going up to 180, and therefore we had the increment operator, and the second for loop was starting from 180 and coming down to 0, and therefore we had the decrement operator. Okay, I believe this is clear to all of you, right? Well, that's it for today, guys. That's how our project was made. Very simple and straightforward to understand. The only thing is like you need to understand the four different functions and the components of the library file that we have used for servo.h library. Okay, if you understand those 4 points, then coding this will be super easy. Okay, well, I believe that you have all enjoyed this session. We have some quiz question for all of you just to check if you were able to understand everything clearly or not. Okay, so yeah, quiz question number 1 over here: which type of signal does an Arduino use to control a servo motor? Which kind of signal do we use? Okay, now if you see, we have two types of digital signals mentioned here, one here, one here, but the difference between these two digital signals is what? That this is a signal which will give either 1 or it will give 0, which is on or off. Okay, however PWM will encode some values and give, right? So which one do you think is the correct one? Obviously the correct one is the answer B. Okay, where we will be giving the PWM signals to the servo motor. Okay, always remember, normal and on and off and PWM both are digital signals. Okay, however PWM are special encoded signals that we can use. Okay, moving ahead to the next question: what is the range of motion for a standard servo motor? For a standard servo motor, what is the range of it? Okay, I'll take a pause. Tell me what will be the correct answer. Well, that's right. The correct range for a usual servo motor is going to be 0 degree to 180 degree. Okay, moving ahead. Third one, which Arduino library is commonly used to control a servo motor? So is it servo H or servo.h or motor control.h, servo motor.h or PWM control.h? We have already seen that the library that we are going to use in today's session, and we have already used that a moment back, was what? Servo.h. So servo.h is the correct answer. Okay, I believe you all have enjoyed this session. So yes, we are done with today's class. Let's see that what we are going to do in tomorrow's class. In tomorrow's session, this is the project that we are going to do, and be ready for tomorrow's session, because tomorrow's session will be a long 1 hour session. In this 1 hour session, we'll create a complete project using all the concepts that you have used so far in the past 5 days. Okay, in this project, we will call this project as motion activated cooling system for pets. What will this project do? In this project, first of all, we will have a temperature sensor, will keep on sensing the temperature, and this Arduino will program it in a way that it will check if the temperature is suitable for our pet or not. Okay, let's assume that the temperature has risen to that level that it's very dangerous for our pet. Okay, so what will happen is this PIR sensor will get activated, and then it will see if the pet is nearby or not by accepting or by sensing the infrared radiation coming from that pet. Okay, now once that is achieved, okay, so let's assume that the temperature is high and the motion is sensed, so sensed motion. Okay, so what will happen is, if the temperature is high and the motion is sensed, it means that the pet is present and the temperature is high. So what we will do is, we'll first of all make an indication in this LED. Now this is a special kind of LED which can glow in 3 different lights, R, G, B, and combination of it we can create n number of different combination of colors. Okay, so here what I'm going to do is, I am going to make it glow red, indicating that something bad is happening, or it's alerted. Okay, the second thing is, we'll turn on the fan. Now once the fan is turned on and the temperature comes down, it cools down, the temperature sensor will keep on checking it, and then it will, once the temperature goes low, right, what will happen is the fan will be turned off and the LED will be green back again. This can be a super cool project if you have pets at your home. Very fantastic project that you can use for maintaining the temperature of your pet's house. Okay, so in tomorrow's session we are going to learn this, how to create this entire project from designing all the way up to coding, and make sure that you are revising all the stuff that you have learned in the past 5 classes, so that we will be using all of these things together. Okay, so stay tuned, guys. Alright, as I already mentioned, that sisyaclass is a online platform which caters to online students learning for school students and college students. So make sure that you go to the App Store or the Play Store to see our application, download it and explore it. You will get much more better content over there also. Well, thank you so much for all the love and all the appreciation that I receive from all of my dear students. Make sure that you're liking this video so that it reaches all the people who might require this. You are sharing this with people who might need this if you have any school projects or college projects, or you're just figuring out how to use a servo motor. And make sure that you are subscribing to this channel so that you don't miss on important updates coming from us. We come with many live videos like this which can help you enhance your skills. In this week we have started with coding and robotics. Next week we'll have advanced version of the same too, and coming to the next week we'll have even much more better sessions for YouTube live sessions. Well, thank you so much for joining this session. I would really like to appreciate your presence. Thank you. We'll see you in the same time tomorrow with a new project. Till then, stay tuned. Tata. Bye bye.